This video will cover Geometry Review, Day 3, numbers 2 through 5. So this is the second set of multiple choice questions if you flip your packet open. Okay, so we left off with number 2. And it says, if triangle A prime B prime C prime is the image of triangle ABC, under which transformation will the triangles not be congruent? Meaning, what one changes the size? So if I took a triangle and I reflected it over the x-axis, it would end up looking like this. So that keeps shape because that's just a flip. Not only does it keep shape, but it also keeps size, angle measure, and distance. Number 2 says translate it left 5 and down 4. So if I took a triangle and I moved it to the left and down, it still looks exactly the same because all I did was slide it. Number 3 says dilation centered at the origin with a scale factor of 2. So if I take a triangle and I scale it up by a factor of 2, it looks bigger because that's a shrink or grow. So that could potentially be my choice because it says not congruent. But let's look at choice 4 anyways. It says that we're going to take a triangle and rotate it 270 degrees counterclockwise about the origin. So it would look something like this. 270 degrees is a huge turn. Notice I just said the word turn. These are your key words that are going to help you to recognize what transformations you actually have in front of you. So that actually keeps the size as well, meaning that choice 3 will create figures that are not congruent. All right, question 3 down here at the bottom, it says if the rectangle is continuously rotated about side W. So here's W, and I'm going to rotate it around. So I'm going to swing this edge over here, swing this one over here, and this whole side will get swung around and around and around and around and around and around and around continuously. So I'm making a figure that starts like this and rotates around and around and around, around and around and around to create a shape that looks like this, which is a cylinder. Choice 4. Okay, so number 5 here says, in the diagram below, a square is graphed in the coordinate plane. A reflection over which line does not carry the square onto itself. This means that we need to find lines of symmetry, because we want it to stay in the same spot. After a reflection. So in this first one it says x equals 5. So I go over to 5 on the x-axis and I draw my line straight up and down. If I reflect over that line, I have to count boxes. So this point, for example, is 6 away from the line, so I go 6 beyond it and I land over here. This one is 6 away from the line, so again 6 beyond it, and I land over here. Meaning my new my new square is over on to the right side, which means it did not carry onto itself. So it looks like choice 1 might be the answer, but let's check out the other ones just in case. Choice 2 says y equals 2. So I go up to where y is 2 and I draw my line. If I look at my points that I looked at the last time, this point would be 3 away from the line, so I'd go 3 beyond it, and I would map exactly onto the other point we looked at. This one is 3 away as well from the line, so I go 3 beyond, meaning the square is staying in the same spot, and this is a line of symmetry. So I'm going to get rid of choice 2. Choice 3 says y equals x. That's the line that goes right through the origin, up 1 over 1. And the diagonal of a square is a line of symmetry. So that one's gone. And for this last one, people choose this because x and y are on the same side, and this is an equation in a different form than what you see in the other ones. But if you just subtract away x, we can plot this, where the 4 is the y-intercept. So I start at positive 4, and because my slope is negative 1, I go down 1 over 1, down 1 over 1, down 1 over 1. So that gives me the other diagonal of the square. meaning that choice 4 is not valid, so we're stuck with choice 1.